The second integration application in the H2 syllabus is to find the volume of solids of revolution, which are basically axis-symmetric volumes generated when we revolve a certain area about the axis. Depending on the question, we can revolve a region about either the x-axis or the y-axis. If we have this shaded area here and we revolve it about the x-axis, we will end up with this solid of revolution. The volume of this solid of revolution can be found using the formula V equals to integration from a to b pi y square dx. Note that when we are using this formula, the solid of revolution must always contain the axis. I will cover more about this in more details later on. In example 1, we are asked to calculate the volume of the solid of revolution when one of the loops of the sine graph is revolved about the x-axis. Now the graph of y equals sine x looks like this. And we are looking at this particular loop over here, and we are going to revolve this loop about the x-axis to obtain a solid of revolution. Therefore, we can apply the formula directly to find out what is the volume. V equals to integration from 0 to pi, since this loop over here spans from 0 to pi, of pi y square dx, which is integrating from 0 to pi of pi sine square x dx. And we have learned how to integrate a sine square x function earlier by simply using the double angle formula. Okay, so this becomes pi integration from 0 to pi of 1 minus cosine 2x divided by 2 dx. And if we proceed to solve this integration, we will get the volume of this to be pi square cubic units. We can also revolve an area about the y-axis to form the solid of revolution. In this case, the formula for calculating this volume will be V equals to integrating a to b pi x square dy. These two formulas may seem confusing, but we just have to remember that if the solid is revolved about the x-axis, then the integration will end with dx. And if the solid is revolved about the y-axis, the integration will end with dy. So it is either integrating pi y square dx or pi x square dy. In example 2, we are now asked to show that the volume of a cone is equals to 1/3 pi r square h, as we have learned in secondary school. A cone can be formed when we revolve a straight line about the axis. Now we are told that if we want a cone of a radius r and a height of h, what we have to do is to revolve the line y equals to h over r times x about the y-axis. So now we have this line over here, y equals to h over rx, which means that when x is equals to r, y will be equals to h. And if we are going to revolve this segment about the y-axis, we will end up with this cone over here. Therefore, for us to find out the volume of this cone, we simply have to do integrating of pi x square dy. So V equals to integrating from 0 to h pi x square dy. And of course, if we are going to find a substitution for the x, we will have to make x the subject. If y is equals to h over r times x, x will be equals to r over h times y. And therefore, I can change this integral into integrate 0 to h pi multiplied by r over h y square dy, which is the same as pi r square over h square integrate 0 to h of y square dy. And if we perform the integration and simplify, we will find that it will be really equals to 1/3 pi r square h. Earlier, I have mentioned that in order to use the given formula, either pi x square dy or pi y square dx, the solid of revolution must contain either the x-axis or the y-axis. But now instead, if I have a region that is bounded by two curves, such that the shaded region does not contain the axis, how can we still find out the volume of revolution? This is very simple. We can simply find out the volume generated by the outer curve or the upper curve like this, y upper, subtracted by the volume generated by the lower curve, y lower. So we have v equals to integrate from a to b pi of y upper square minus pi y lower square dx. Likewise, if we are revolving it about the y-axis, we will have v equals to integrate from a to b pi of x right square minus pi of x left square dy. In example 3, we have the region bounded by the graph of y equals to ex, y equals to 2, and the y-axis, which means we are looking at this region over here, and we are now going to revolve this region about the x-axis to form a solid of revolution, which should look something like this. And we can quite easily see that this volume of revolution does not contain the x-axis. And therefore, in order for us to find out the volume of this solid, we will have to do a subtraction. The outer curve in this case is the line y equals to 2, which when we revolve will give us a cylinder. And therefore, we can simply make use of the volume of a cylinder instead of integration to find out the volume of this cylinder before we subtract it by the volume generated by the exponential graph. So we have v equals to pi times r. The radius of this cylinder will be 2, and the height of this cylinder will be ln 2. So we have pi 2 square times ln 2, and we are going to subtract it with integration from 0 to ln 2 of pi y square dx. And if we simplify, we will get 4 pi ln 2 minus integrating 0 to ln 2 of pi e to the power of 2x dx. And we can solve this integration pretty easily to eventually arrive at 4 pi ln 2 minus 3 over 2 pi units cubed. And that's it.